In Unit 2, we're going to investigate polynomials and rational functions. At first, we're going to focus on a particular type of polynomial referred to as a quadratic function. But let's start more general than that. Let n be any non-negative integer, and let a sub n and a sub n minus 1 and a sub n minus 2 all the way down to a sub 1, a sub 0. Let those be real numbers, and a sub n does not equal 0. Then this function f of x, given by that, so a sub n times x to the n, plus a sub n minus 1 times x to the n minus 1 power, etc., all the way down to a sub 1 times x plus a sub 0, which is just a constant. This is called a polynomial function of x with degree n. So the degree is the highest power of your variable. So in this case, whatever n is. So even if it's not in descending order, you have to pick out the highest power of x, and that tells you what the degree of the polynomial is. If the degree winds up being 0, then it's just called a constant function, because x to the 0 is just 1. So if it's constant, you really just have a sub 0. So for example, f of x equals 5. F of x equals negative 3.2. That's a constant function. If the degree is 1, it's called a linear function. So that would be like f of x equals 2x plus 3. So it's just a straight line. And we've already talked about those in the last unit. On the other hand, if the degree is 2, we call it a quadratic function. And a lot of times you'll see it in the form f of x equals ax squared plus bx plus c. Obviously, a cannot be 0, or then it just becomes a linear function. And so these are the ones we're going to focus on, are the quadratic functions. What if I asked you to find the vertex and the x intercept, or intercepts, of the parabola? So we need to talk about the different ways we can do this. So we could use our calculator. So if I go ahead and grab my calculator and I punch this in, 2x squared plus 12x plus 17, and then just zoom standard window. There's my parabola. Opening upward, I can see it looks like the vertex happens around x equals 3. I could hit trace and type in 3. Oops, I'm sorry, negative 3. There we go. So it looks like the vertex is at negative 3 comma negative 1. Now, how could I be sure about that? Well, what I could do is use the calculate menu, which is second, and then the trace button. And I could calculate a minimum, because this parabola is opening upward. If it were opening downward, I would choose maximum. So I'm going to choose minimum, number 3. And it says give me a left bound, so I'll go to the left of the minimum, press enter. Go to the right of the minimum, press enter. And then give it a guess, you just press enter again. And sure enough, that minimum is at negative 3, negative 1. So I can write my answer here. The vertex is at the point negative 3, negative 1. Now the x intercepts I can also do on the calculator. And so I'm going to press second trace to get to the calculator menu. And an intercept, x intercept, is a 0 of the function. So I'm going to choose number 2. And let's go to the left of that first x intercept. Press enter. Then let's go past it. Enter. Give it a guess. Just press enter. It looks like there's a 0 at approximately negative 3.7. We'll go 3 decimals. 3.707. Negative 3.707. And then we'll find the other one. So this is the x intercepts. Unless the vertex is right on the x-axis, you're going to get, well, if the vertex is on the x-axis, you'll get one x-intercept. If the vertex is below the x-axis, you'll get two x-intercepts, like this case. Or if the vertex winds up being above the x-axis, then there won't be any x-intercepts because it never crosses the x-axis. All right, so now I'm going to find the other 0, second trace, calculate 0. Go to the left of that, and then go to the right of it, and then enter for the guess. And the other 0 is negative 2.293 if I round it. Negative 2.293. Negative 2.293. All right, so there's one way to get your answers. Now, let's talk about what if we could not use a calculator. Well, there's a technique to find the vertex called completing the square. And I'll actually show that in the next example, so I'm not going to do that here because it's with the same problem, completing the square. And that'll put this equation in the standard form, and then you'll be able to see the vertex from that standard form of the equation. There's a shortcut for finding the vertex, and it turns out when you want to find the vertex and it's in this form, ax squared plus bx plus c, the vertex is going to be at x equals the opposite erase that, let's put it out in front, the opposite of b over 2a. So in this case, b is equal to positive 12, so it's going to be the opposite of positive 12 over 2 times a, and a is equal to 2. And so that's negative 12 over 4, which is 3. And sure enough, that's what we found the vertex to be at, x equals negative 3. Now this x equals negative b over 2a is helpful, but that only gives you the x coordinate. Then we have to still figure out the y coordinate. And in order to do that, we're going to go ahead and plug in that x value, negative 3, everywhere where we see an x, and then we have to evaluate it. So we would do 2 times negative 3 squared, which is going to give you a positive 9 times 2 is 18, plus 12 times negative 3, which is negative 36. So it's negative 18, I'm sorry, positive 18 minus 36, that's negative 18, plus 17 gives us a negative 1. And so that's not too bad to do. You use x equals negative b over 2a to find the x coordinate of your vertex, and then plug that into the function, do f of that answer. And that'll give you the y coordinate, and so then you'll have your vertex. Now as far as finding the intercepts, it's important to understand the x intercepts, that's the same as the zeros of the function, which is the same as the roots of the function. All those terms are synonymous. So if a question says find the x-intercepts, or find the zeros, or find the roots, all the same thing. And there's 2 ways you can do that. You can try to factor, and if factoring works, you can solve that. But if factoring doesn't work, you can always resort to the quadratic formula. If I can spell that correctly. Quadratic formula. So it's nice if you can factor it, but if you can't, quadratic formula. And in this particular case, you cannot factor it, so you would have to use the quadratic formula. And just as a refresher on that, so your a was equal to 2, your b was equal to 12, and your c was equal to 17. 2, 12, 17. So the x-intercepts are going to be x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And so you'll plug those numbers in and simplify as much as you can. And if you use a calculator after you simplify it, you should get these 2 decimals. All right. But if we can put our quadratic in the standard form that I had mentioned, which is a times the quantity x minus h quantity squared plus k, then we're going to know what the vertex is right off the bat. the vertex will be h comma k. And it's important to understand that h is here, and we're not including the minus. So if I have an equation that looks like, let's say, y equals 2 times x minus 4 squared plus 7, then the vertex is going to be 4 comma 7. But if I had, let's say, y equals 2 times x plus 4 squared plus 7, now the vertex is going to be negative 4 comma 7. So the x-coordinate is the opposite of what's inside the number inside the parentheses after the x. All right, and then the line of symmetry, which is the line that splits the parabola in half and goes right through the vertex, that'll be a vertical line, so it'll be the equation x equals whatever h is. So let's do that. Let's work through completing the square to put this in that standard form so we can see the vertex right off the bat. Now, you should be familiar with completing the square, but I'll walk through the steps in case you forgot. The first thing you need to do, put it in this order, and the leading coefficient for x squared needs to be 1. And if it's not, you need to factor that out. So I don't have to factor it out of all the terms, just the terms that have x in it. So I'm going to factor a 2 out of this, and I'll have x squared plus 6x. And then I'm going to leave some room, and then I still have that plus 17. So to make sure you did it correctly, if you distributed the 2, you should wind up with exactly what we started with. All right, so now the next step is we would like what's in the parentheses to be a perfect square, which means we want to be able to factor it, and the 2 factored binomials will be exactly the same. So then I could write this, instead of 2 sets of parentheses, I could write it as a quantity squared. So that's my goal. So I want to make this a perfect square. So how am I going to do that? Well, all I have to do is look at this number here, divide it by 2, and square it. So that's going to give me 9. So I know I need to add a plus 9 in here. Now if I redistribute, if I just put a plus 9 there, and I distribute this 2, I wind up with 2x squared plus 12x plus 18 plus 17. And that's not what I started with. I didn't have this plus 18. So I need to offset that in my equation, in my expression I should say. I need to offset that by taking away 18 as well. So now the plus 18 minus 18 cancels out, and now I do have what I started with. So what I really did was add 18 to my expression. So now what I need to do to offset that is subtract 18 outside the parentheses. So now I haven't changed my original function, and if you simplify all this, you'll wind up with what we started with. All right, now I can factor the inside. That's going to become x plus 3 times x plus 3. And then 17 minus 18 is a negative 1. But I can write this in condensed form and write x plus 3 quantity squared. And now I have put this in standard form. So I'm going to be able to tell what the vertex is. So that's the goal, is to put it in this form. And by completing the square, I've put it in that form. So once again, I'll walk you through the steps. You can fast forward if you don't need to see it again, but I think it's important to explain. And you might want to even jot down the steps as I say them. So step 1, factor out a leading coefficient of x. So I need to factor out a 2 from all the terms that have an x. And then I'll leave a space. Then I need to figure out what would make this a perfect square in the parentheses. So I look at the 6, I divide that by 2 and square it. 6 divided by 2 is 3, squared is 9. So I'm going to add 9 in the parentheses. Now since there was a 2 out in front, 2 times 9 is 18. So to offset that plus 18, I need to do a minus 18 outside here. Now I can rewrite this as x plus 3 times x plus 3, or x plus 3 squared, minus 1. And now by looking at that, I can see that the vertex will be the opposite of the number inside the parentheses, so a negative 3, and then the number outside the parentheses, negative 1. And so that's how I can find the vertex, by putting it in that standard form. The directions said write it in standard form, so I'm done there. Let's look at another example. Write the equation of the parabola that has a vertex at 4, negative 7 and passes through the point 3, negative 10. Okay, so let's start with what we know. We know that if we have a function that looks like this, that the vertex is going to be h comma k. And they told me what the vertex is. So I know what h and I know what k are. So I have a, x minus h is a 4, and k is a negative 7. Now the only thing I still don't know, though, is what number goes in front of the parentheses. But they gave me some other information. They said the point 3, negative 10 is on this parabola. That means that f of 3 should equal negative 10. So I'm going to use that to figure out what a is. So I'm going to plug in negative 10 for f of x, or for y, and then a, and I'm going to plug in 3 for the x, minus 4 squared minus 7. Oops, I left the squared off of here. Why didn't anybody tell me? All right, now I should be able to solve for a. So if I add 7 to the other side, I get negative 3. And then 3 minus 4 is negative 1 squared is 1. So a is equal to negative 3. And that was what I'm looking for right here. And then I will be complete. I will have the equation of my parabola that has the vertex at 4, negative 7 and passes through the point 3, comma, negative 10. So as my final answer, let's write it over here. F of x equals a, which is negative 3, times x minus 4 squared minus 7. And that's a parabola that passes through the point 3, negative 10, and it has a vertex of 4, negative 7. All right, here's the problems from section 2.1, starts on page 96.